Located some 2400 light-years away in the constellation Cygnus, the Veil Nebula is the remnant of a supernova explosion. The source supernova, which exploded over 20,000 years ago, was a star 20 times more massive than the Sun. At the time of the explosion, the supernova would have appeared brighter than planet Venus in the sky and visible in the daytime. The Veil Nebula consists mostly of interstellar matter such as oxygen, sulfur and hydrogen that were swept up by the material flung off by the exploding star. It still shines today because of excitation due to the collision between this expanding shock wave and the interstellar medium. The view here covers an area more than 40 light-years across, but it only shows the western segment of the whole nebula. The entire nebula is over 100 light-years across, covering an area of sky that's 6 times bigger than that covered by the full moon. The nebula is currently expanding at a velocity of about 1.5 million kilometers per hour, fast enough to travel from Earth to Moon in 15 minutes. The Crab Nebula is a supernova remnant and pulsar wind nebula in the constellation of Taurus. This glowing relic has been expanding at a rate of about 1500 kilometers per second since the star exploded, and it is now approximately 11 light-years wide. Located about 6500 light-years away from Earth, the nebula has a rapidly spinning neutron star embedded at its center. The neutron star known as Crab Pulsar powers the nebula's interior bluish glow. The blue light comes from electrons whirling at nearly the speed of light around magnetic field lines from the neutron star, which is the crushed, ultra-dense core of the exploded star. Like a lighthouse, the neutron star produces twin beams of radiation. From Earth, it appears to pulse 30 times a second due to the neutron star's rotation sweeping the beams across our line of sight. Rising like a giant horse from turbulent waves of dust and gas in this view is the Horsehead Nebula, also known as Barnard 33. The image here shows the region in infrared light, which has longer wavelengths than visible light and can pierce through the dusty material that usually obscures the nebula's inner regions. The result is a rather ethereal and fragile-looking structure made of delicate folds of gas, very different to the nebula's appearance in visible light. The Horsehead Nebula is located more than 1300 light-years away in the constellation Orion. The nebula formed from a collapsing interstellar cloud of material and glows due to illumination from a nearby hot star. The harsh ultraviolet glare from one of the nearby stars is slowly evaporating the nebula. Gas clouds surrounding the nebula have already dissipated, but the jutting pillar, composed of thick clumps of material, are more resistant to erosion and remains intact. Astronomers estimate that the nebula has about 5 million years left before it too disintegrates. The Horsehead Nebula is a well-known photodissociation region. In such a region, ultraviolet light from young, massive stars creates a mostly neutral, warm area of gas and dust between the fully ionized gas surrounding the massive stars and the clouds in which they are born. This UV radiation strongly influences the chemistry of these regions and acts as a significant source of heat. These regions occur where interstellar gas is dense enough to remain mostly neutral, but not dense enough to prevent the penetration of UV light from massive stars. What looks like mountains and valleys speckled with glittering stars here is actually the edge of a nearby young star-forming region called NGC 3324 in the Carina Nebula. Captured in infrared light by the James Webb Space Telescope, this image reveals previously invisible areas of star birth. Also known as the Cosmic Cliffs, the region is actually the edge of a gigantic gaseous cavity within NGC 3324, roughly 7600 light-years away. The tallest peaks in this image are about 7 light-years high, and the cavernous area has been carved from the nebula by the intense ultraviolet radiation and stellar winds from extremely massive stars located in the center of the bubble above the area shown in this image. The high-energy radiation from these stars is sculpting the nebula's wall by slowly eroding it away, and dramatic pillars tower above the glowing wall of gas resisting this radiation. The steam that appears to rise from the celestial mountains is actually hot ionized gas and hot dust streaming away from the nebula due to the relentless radiation. Carina Nebula resides in the constellation Carina and is also home to the Keyhole Nebula and the active, unstable supergiant star called Eta Carinae. The Lagoon Nebula is located about 4,000 to 6,000 light-years away in the constellation Sagittarius. It is an incredible 55 light-years wide, 20 light-years tall, and is faintly visible to the naked eye. The image here shows only a small part of this turbulent star formation region, about 4 light-years across. The part seen here is the center of the nebula, where dust masks most of the objects within. The image, which maps the emission from the nebula's ionized gas, shows hydrogen in red color and nitrogen in green. The blue-white flare at the upper left of the image is scattered light from a bright star just outside the field of view. Lagoon Nebula is home to its own star cluster called NGC 6530. The massive stars embedded within the nebula give off enormous amounts of ultraviolet radiation, ionizing the gas and causing it to shine. In addition to these young stars, there are also many dark nebulae of considering gas and dust which are on their way to becoming protostars and ultimately fully fledged stars like those already formed nearby. The nebula also includes a tornado-like structure caused by a hot O-type star that emanates ultraviolet light, heating and ionizing gases on the surface of the nebula. Lagoon Nebula also contains at its center a structure known as the Hourglass Nebula. In the past, 4 bright objects associated with newborn stars called Herbig Haro were detected within the hourglass, providing direct evidence of active star formation by accretion within it. The Twin Jet Nebula lies some 2100 light-years away in the constellation Ophiuchus. It is a bipolar planetary nebula with 2 iridescent lobes of material stretching outwards from a central star system. The glowing and expanding shells of gas visible in this image represent the final stages of life for an old star of low to intermediate mass. The star has not only ejected its outer layers, but the exposed remaining core is now illuminating these layers, resulting in a spectacular light show. Bipolar nebulas like the Twin Jet Nebula have 2 stars at their center, unlike ordinary nebulas. The characteristic shape of the wings of the Twin Jet Nebula is caused by the motion of the two central stars around each other. As one of the two stars expels its outer layers, the other disrupts the outflow of material to form the bipolar shape. The Twin Jet Nebula's wings are still growing, and by measuring their expansion, astronomers have calculated that the nebula was created only 1200 years ago. Within the wings of the nebula, starting from the star system and extending horizontally outwards like veins, are two faint blue patches. Although these may seem subtle in comparison to the nebula's rainbow colors, these are actually violent twin jets streaming out into space at speeds in excess of 1 million kilometers per hour. These towering tendrils of cosmic dust and gas sit at the heart of M16 or the Eagle Nebula. Known as pillars of creation, this is a region where young stars are forming or have barely burst from their dusty cocoons as they continue to form. The pillars are composed of cool molecular hydrogen and dust that are being eroded by photoevaporation from the ultraviolet rays of relatively close and hot stars. The leftmost pillar is about 4 light-years in length, and the finger-like protrusions at the top of the clouds are larger than the solar system. They are made visible by the shadows of evaporating gaseous globules which shield the gas behind them from intense ultraviolet flux. Evaporating gaseous globules are themselves incubators of new stars. The stars then emerge from the evaporating gaseous globules, which then are evaporated. Stretching roughly 4 to 5 light-years, the pillars of creation are a fascinating but relatively small feature of the entire Eagle Nebula, which spans 70 by 55 light-years. The nebula is located 7,000 light-years from Earth in the constellation Serpens. Formed by a star throwing off its outer layers as it runs out of fuel, the Ring Nebula sits relatively close to Earth at roughly 2,500 light-years away. Planetary nebulas like Ring Nebula consist of expanding shell of ionized gas ejected from a single dying star at the center. Only a few thousand years ago, that star was still a red giant that was shedding most of its mass. The hot core now ionizes or heats up this expelled gas, and the nebula responds with colorful emission of light. This image from James Webb Telescope shows the Ring Nebula in unprecedented amount of detail. The bright ring that gives the nebula its name is composed of about 20,000 individual clumps of dense molecular hydrogen gas, each of them about as massive as the Earth. Within the ring, there is a narrow band of emission from polycyclic aromatic hydrocarbons, complex carbon-bearing molecules that we would not expect to form in the Ring Nebula. Roughly 10 concentric arcs are located just beyond the outer edge of the main ring. The arcs are thought to originate from the interaction of the central star with a low-mass companion orbiting at a distance comparable to that between Earth and Pluto. The Orion Nebula is only 1,500 light-years away, making it the closest star-forming region to Earth and one of the brightest nebula visible to the naked eye. Located just below Orion's belt in the constellation of Orion, It is estimated to be 25 light years across and has a mass of about 2,000 times that of the Sun. Ancient Maya of Mesoamerica believed it to be the cosmic fire of creation, which is very befitting given that it is an enormous cloud of dust and gas where a vast number of new stars are being forged. Turbulence from deep within these clouds creates high-density regions called knots. These knots contain sufficient mass that the gas and dust can begin to collapse from gravitational attraction. As it collapses, pressure from gravity causes the material at the center to heat up, creating a protostar. Over time, this core becomes hot enough to ignite fusion and a star is born. Not all of the material in the collapsing cloud ends up as part of a star. The remaining dust can become planets, asteroids, or comets, or it may remain as dust. The nebula's bright central region is also the home of 4 massive young stars that shape the nebula. The 4 hefty stars are called the trapezium because they are arranged in a trapezoidal pattern. Ultraviolet light unleashed by these stars is carving a cavity in the nebula and disrupting the growth of hundreds of smaller stars. This image by the James Webb Space Telescope reveals details of the structure and composition of the Tarantula Nebula, as well as dozens of background galaxies. The nebula gets its name from its long dusty filaments and is located about 160,000 light-years away in the large Magellanic Cloud Galaxy. It's the largest and brightest star-forming region near our own galaxy and also home to the hardest, most massive stars known. The center of the nebula has been hollowed out by the radiation from young, massive stars seen in sparkling pale blue color in this view. Only the densest surrounding areas of the nebula resist erosion, forming the pillars that appear to point back towards the cluster of stars in the center. A star cluster known as NGC 2070, which includes the compact concentration of stars known as R136, produces most of the energy that makes the nebula visible. The pillars of the nebula are also home to still-forming stars which will eventually leave their dusty cocoons and help shape the nebula. Fluffy, tan-colored nebula clouds with rust-colored highlights surround a black central area. Within that area, the focal point of the image is one large yellow star with 8 long, thin points. To the right of this star is a bright star cluster in an oval shape. The stars within the cluster look like tiny pale blue sparkles, and the cluster is more densely packed at its core, which scatters outward. Towards the bottom of the image, multiple arms appear to spiral out of a cloudy tan knob, resembling a spider or a squid structure. Other blue and yellow 8-pointed stars as well as distant galaxies are dotted throughout the image. A massive black hole about 9 times the size of our Sun also resides within the nebula.